Welcome back, fifth graders. Today we're going to have another exciting science lesson on weathering. I hope you enjoyed the video from the previous video where we learned about how important it is as scientists to gather background knowledge and know the materials that we're using and how to use them correctly in order to conduct an experiment. So I hope you had fun with that lesson. Now today we're going to continue this thought on weathering, and we have already set up our glossaries by looking at the definitions and recording those words that this author wants us to use. So now we're going to continue in our science notebooks, and our learning targets are: I can listen and follow along with today's lesson in my notebook. I can use the definitions the author gave to understand the science concepts in the article. And finally, I can show my understanding by creating a flow chart for chemical weathering. So we're going to do some of this together today, and then we will send you off to do a little bit on your own. And it's important to be thinking about these learning targets as we go, and that your end goal for today is that you're going to be able to show your understanding in a flow chart for chemical weathering. But the first thing we're going to do today is we are going to look at that weathering article, and we're going to read some of it together and use the definitions that we got in the previous lesson to help us understand what weathering is, and then going deeper into what physical weathering is. We're going to do this part together today, and then I'm going to ask that you go and do this part, the chemical weathering piece, on your own when we are done. So I'm going to pull out my science notebook, and I'm going to open to the glossary that we've been working on. I would encourage you to do the same with us. And open to the words that we added in the previous lesson. So together we added weathering, physical weathering, minerals, abrasion, and landslides. Then your assignment was to add the next 7 words that the author gave you on your own. As we read today, now is going to be a good time for us to use what we understand and learn from the reading to add a little picture or a little illustration next to each of these words. So as we begin, let's zoom in here a little bit. We're going to read this first part together. Weathering. Pebbles and sand are pieces of rock. Pebbles are pretty big. You can count a handful of pebbles. Pieces of sand are tiny. You can't count the particles in a handful of sand. All pebbles and sand particles start out as huge masses of rock the size of mountains. How do mountains break down into pebbles and sand? The answer is weathering. Weathering is the breaking apart of rocks into smaller pieces. Weathering happens to all rocks when they are exposed to water and air. So I'm going into my notebook at my glossary and looking at that definition that we wrote down. Weathering is the process by which larger rocks crack and break apart over time to form smaller rocks. Something that I am thinking about in this passage, and that image that was put into my head as I read, was this image of rocks starting, pebbles and sand particles starting as a huge mass of rock the size of a mountain. As soon as the author wrote that in there, that this was the size of a mountain, and that all pebbles and rocks started from a rock that big, that weathering is that breaking down and taking those pieces, and eventually they break down far enough to just being tiny little pebbles and sand. So that created a very vivid picture in my mind that I thought I could add to my illustration to kind of show that rocks usually start as these big mountains, and that weathering eventually breaks them down into tiny little pieces of pebble or sand. And that's what that process of weathering is breaking down rocks. Let's keep reading. Physical weathering. Rocks break down in two ways. Physical weathering makes rocks smaller but does not change the rocks in any other way. When a big rock falls from the side of a cliff, it breaks into lots of smaller rocks. All the minerals in the small rocks are the same as the minerals in the big rock. So, physical weathering, again, this author gave us a really clear picture where there's a big rock falling from a cliff and breaking into smaller rocks. I might add that to my physical weathering, drawing an illustration. Maybe I have a cliff here and there's like a big rock on the edge of it and it falls down and it breaks. Into smaller parts. And then talking about minerals. All the minerals in the rock, in the small rock, are the same as the minerals in the big rock. A mineral is that ingredient of a rock. So remember that many rocks contain a couple of minerals or a couple of ingredients. And when physical weathering happens, none of those ingredients change. They just break apart into smaller pieces. Now, many different minerals have different colors, and that's why if you pick up a rock, you can kind of see different shades and colors and specks to it. So as I am thinking of an illustration, I might kind of maybe shade some of these lighter and darker to show that different minerals can have different colors. And it's not always just a form of gray. There are minerals that are red or orange, maybe like a lighter sandy kind of a color. And I know we'll get more into that as we start reading about the chemical weathering, because some of my definitions over here, like calcite, is one of those minerals. Limestone is a rock that's made mostly of calcite, but it's got a couple different minerals within it. So a mineral is just one ingredient of a rock. And again, in physical weathering, the minerals are still the same. They are not changing. They are just breaking apart into smaller pieces. When rocks get hot and then cold, they can crack. Sometimes water gets into cracks in rocks. Water expands when it freezes. It can expand enough to break big sections of rock along the crack. When ice melts, the rock may break into smaller pieces. Down below, there's two pictures here that this author included to help me get a visual of some of these physical weathering examples. The first one, the caption says, "Physical weathering of cliffs." This is similar to what we just drew in our notebook, where rocks from the cliff are falling down and breaking apart. And we can see that by these broken pieces versus the larger chunk of rock up above. This picture says a rock weathered by freezing and thawing of water. So this picture is a demonstration of this last paragraph that we just read. When rocks get hot and cold, they can sometimes crack. Sometimes water will get into those cracks, and then when it freezes, and it's showing like there's some snow here, when that water freezes, or even these icicles on the side, the water expands or gets bigger, which pushes the rock apart. Then when it warms up again and the water melts, the rock stays separated with a crack. And that's shown in that picture. Let's keep reading. Roots of trees and bushes can grow down into cracks in rocks. As roots grow, they make the cracks bigger. Sometimes the cracks get so big that the rock falls apart. When rocks bang into one another, they get worn down. Rubbing, grinding, and banging is called abrasion. Abrasion is a kind of physical weathering. It happens when rocks fall in landslides, tumble in flowing water, or crash around in waves. Wind can blow sand against rocks. This sandblasting weathers the rocks. So now I'm getting some more pictures in my head, and there's more pictures included for the author, or that the author gave us to help our understanding. So here is a picture of this first paragraph here, where the caption says, "Tree roots grow and break rocks." You can see that the tree has grown down and is continuing, the tree has grown up. The roots continue to dig deeper down in between the cracks and are breaking those rocks apart. Down here is a picture of the sand abrasion. And now that I remember that abrasion, if I look back, is the rubbing, grinding, and bumping of rocks that cause physical weathering. When sand is rubbing on these rocks through the wind or the air, or even from sliding down, they rub other parts of the rock away with it, and that's called abrasion. And this is another form of physical weathering, where sand pieces and particles in the air, the blowing sand, can weather rocks into interesting shapes. So sometimes when there's sand blowing along with the air, it's wearing away and brushing away at that rock. We might think of abrasion as possibly like a form of using sandpaper. And when we use sandpaper to make something smooth or rub away parts of wood, or even using sandpaper on other objects, we're not changing. If I'm sanding down some wood, I'm not changing the wood. All I'm doing is brushing away some of the rough pieces to smooth it out. So if sand on paper does that to wood, sand in the air or sand rolling down these cliffs also break away at other pieces of rock. So if I'm going to add a picture of abrasion, I'm looking for clues that the author gave me or pictures to show what I might be picturing in my head. And this author gave us examples of a landslide, of waves and crashing the waters with the rock and banging the rocks against each other in the ocean, or the wind with the sand. So I'm kind of, personally, I thought the waves and the example kind of like a beach where you have all that sand underneath and the water is moving that sand and rubbing all of those little particles together, that is a form of abrasion, that they're constantly rubbing against each other. And then a landslide being the sudden movement of Earth's materials down a slope. The difference is that just like this is at a slope, a landslide would be like those materials weathering away down that angle. You might think of a landslide like you've seen in movies or before with snow or an avalanche, but a landslide would be those pieces of rock and minerals moving down that slope. So really quickly to review, this idea of physical weathering is weathering that changes the shape or the size of rocks without changing the rock, like what makes the rock. The rock is still the same, it's just broken into a smaller piece. So now I would like us to flip to out of our glossary into the place in our notebooks where we are writing about our thoughts and our ideas. And we're going to title this top section Physical Weathering. And you're going to leave a space about halfway through for chemical weathering. And this is what you are going to do on your own after we finish here. Now, going back to our learning targets for today, we have been listening and following along. We used those definitions that the author gave us to deepen our understanding as we read the physical weathering part of the article today. And now together we are going to create a flowchart for physical weathering, and we'll work through what a flowchart is and the important pieces that we need to have before you go to complete these 2 learning targets on your own for chemical weathering. In a flowchart, we get to draw and show what happens to things over time. So we're going to make a 3-part flowchart for physical weathering, where a piece of rock, how it might start in the beginning, something happens to it in the middle, and then what it looks like at the end. We talked about numerous different ways that rocks can break apart through physical weathering. Now we're going to pick one. You may pick one that I pick, or you can pick one of your own. Some of them that we talked about were how rocks fall off of cliffs and break. Sometimes they get hot and they get cold and they expand and crack. Sometimes water gets into them. Maybe a tree's roots grow into them and they crack apart. Or smaller rocks rub and grind against them and break more pieces of that rock off through abrasion. So if you want to choose one of those physical weathering examples, go ahead and draw the 3 parts on your own. Today I'm feeling like I'm going to draw the ice and the cracking of the rocks by water freezing. So I might start, I'm going to use this picture to kind of help me. I might start with a bigger rock because again, physical weathering is the breaking down of the rock, and then show that when it rains, draw that rock again, or when it freezes, that water seeps down into the rock. Through those cracks. And then finally, the rock, when that water or that ice melts, it leaves bigger cracks and breaks that rock apart. So this is creating that flow chart for physical weathering. I might add some captions and some definition or some details to show what's happening in each picture. So here, the rock is large and one whole piece. In this picture, rain and water get into cracks. The water freezes. and expands. And then finally, when the ice melts, and leaves larger cracks, that break the rock apart. So here is a 3-step flowchart for an example of physical weathering. Now you are going to turn to this chemical weathering section and use your glossary with the terms you added in the previous lesson to read this section on your own, add the illustrations for chemical weathering, and then draw a 3-step flowchart for chemical weathering along with the explanation of how that example happens. When you're done, upload a picture of this page that we did together, your physical and chemical weathering flowcharts, along with your glossary with the updated pictures. Awesome work today. This is going to help us out a ton as we go to do our own investigations here in a couple of weeks. Keep up the great work.